Let us solve this question together. A uniform rod of length 1.5 meter is balanced on a pivot placed 0.5 meters from one end. A 40 Newton weight is hung at the shorter end. Find the unknown weight at the longer end to keep it balanced. To solve a question of this nature, we are going to use the principle of moment. Okay, and the principle of moment says that the sum of the clockwise moment is equal to the sum of the anti-clockwise moment. But before you solve it, a question like this, you need to draw out what is happening so that you can be able to see what is happening and solve it in a more simpler way. So let's draw what is in this question. The uniform rod of length 1.5 meters. So you have a rod that is 1.5 meter long. So let's say this is our rod. And then the length is 1.5 meters. So that means from here so the length of that entire rod is 1.5 meters. Then the question proceeds to say that it's balanced on a pivot placed 0.5 meters. So now we have a pivot that this thing is resting on. This thing is resting on a pivot that is 0.5 meters. So if this complete length is 1.5 meters and this thing is resting on a place that is 0.1 meter from one end. So let's say if from this side, from this end to this place is 1 meters, then from here to here will be 0.5 meter. Is that understood? So let's say this is where the pivot is resting. So that means from the end, from this end to this here, the distance is 0.5 meters to this place where this thing is resting. So the distance is 0.5 meters. So that means from here to this end is going to be 1 meter. So 1.0 will give us 1.5 meters. And then the question says that a 40 Newton weight is hung at the shorter end. So this is the short end, this side is the shorter end. A load, that means a load is hanging here. This is the load, and the load is 40 Newton. And then the question says that we should find the unknown weight at the longer end to keep it balanced. So this is the unknown side now. What weight now is it going to be hung here in order to make it balanced? So let's call this one X because we don't know what the weight on this side is. So this is what we asked to find. So now, like I said earlier, we are going to use the principle of moment to solve this. So the principle of moment says that the sum of the clockwise moment about a point is equal to the sum of the anti-clockwise moment about a point. So looking at this road, and this is the center where it is balancing, then the sum of the moment on this side is equal to the sum of the moment on this side. This is going to be the clockwise moment, and this is going to be the anti-clockwise. So moment, the form of moment is force times distance. So that means the moment on this side is equal to moment on this side. So moment on this side is going to be force, which is 40 Newton multiplied by the distance, which is 0.5. So moment of this side is 40 multiplied by 0.5 is equals to, and the moment of this side also is going to be the distance from here to here multiplied by the weight here, weight here. So here from here to here, like we know, is 1 meter, because if here is 0.5 meters, then from here to here is going to be 1 meter. So from here to this side is 1 meter. So that means 1 times the weight, put it, times the weight here. Now we don't know the weight here, which is X. This is what we asked to find. So what we have is 40 multiplied by 0.5. So 40 multiplied by 0.5 is going to be 20 is equals to, then 1 times X is the same thing as X. So this is the implied that our X is equals to 20. So this is the weight which is measured in Newton, just like this one. So this is the weight that is going to be placed on this place in order to balance this beam or this rod. So that's the answer.